Hi, I want to do one more example with you finding quantum numbers. So I chose iron, all right? I wrote the orbital notation and electron configuration for iron. And let me show it to you just so you can see it. There's iron right there. Okay, there's iron. So I did core notation, argon, 4s2, 3d6, did the orbital notation, followed Hund's rule where I put one electron in each orbital, and then I went back and doubled up. If you need help on this, again, go to my playlist that says atomic structure, and you're going to look for orbital notation. Okay, I wanted to give an address for that electron right there. We're going to use these four quantum numbers. So let's start with the principal quantum number. What's the energy level? N equals 3 is the third energy level. Now, D is going to be my angular momentum, the azimuthal quantum number. D, remember, is 2. So my angular momentum, when I'm at D, we give D the number 2. Okay, we give D the number 2. Just remember you start with S0, and then you can figure out P1, D2, F3. Okay, now we need our M sub L. So this is going to be the magnetic quantum number. You can label these. Remember, M sub L is negative to positive L. So this would be M sub L minus 2, M minus 1, M 0, M plus 1, M plus 2. So my M sub L is a plus 2, and that totally fits because its limits are going to be negative L to positive L. That's within those limits. And then the M sub S, so my spin quantum number, this is spinning up, so it's plus 1/2. Nice. Do you know what? I think we should do one more. Let's do one more. I want you to experience one more. Okay, let's do, I wish you were here and you could tell me which one you want me to do. Let's do one in a different block. Should we do F? Let's do F, okay? Uranium, our last naturally occurring element. Woohoo, that's a good one, uranium. So if we go to our core notation, we're going to have radon, and then we'll have 7s2 and 4f4. Let's do the orbital notation just for this. We'll have 7s and then 4f. F has 1, 2, 3, 4, 5, 6, 7. It has 7 orbitals because it fits 14 electrons. So here's my 4f. And we have 4 electrons, 1, 2, 3, 4. Again, using Hund's rule, we put 1 electron in each orbital. After they're all filled, then we go back and double up just because of stability. Okay, you guys, let's do 2. I want to do 2 on this. Let's first do this one. Okay, I want to do that electron right there. So what's the energy level? N equals 7, energy level 7. What's the subshell? It's S, so that's a 0. So the angular momentum is going to be 0, azimuthal. Now remember, the M sub L can only be negative L to positive L. Well, this is 0, so M sub L has to be 0. That's the magnetic, is 0. This is actually called M sub 0, okay? And then the spin quantum number, this is spinning down, negative 1/2. There's the address for that electron. Cool. Okay, let's do we'll do this one right here, okay? Let's do that electron. Okay, what's the energy level? 4. This is energy level 4. N equals 4. Remember, you're looking specific for that electron, so you look at its energy level. Even though this is a 7 over here, don't care. We're at the 4th energy level for the F block. So 4. The L is going to be, all right, it's F, that's a 3. Now just a reminder, remember the maximum the L can be is 1 less than N, and that totally fits. 3 is going to be 1 less than 4. So our F block is a 3. Now our M sub L. So the M sub L is negative L to positive L. Here are all of our possibilities. We could have minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Notice 1, 2, 3, 4, 5, 6, 7. 7 orbitals. So this one, we're just going to start with a negative and make our way across. This is M minus 3, M minus 2, M minus 1, M 0, M plus 1, M plus 2, M plus 3. So that magnetic spin the M sub L is a -2. Now it's spinning up, so the spin quantum number, +1/2. There you have it. So I'm hoping that this is pulling everything together for you. You'll be asked questions where they give you 4 quantum numbers and you have to see if it's permissible. You could memorize these. You can also look at the periodic table and it will tell you if it works or not. The other way that you'll be asked is you'll be given an element like uranium and you'll be asked to give the 4 quantum numbers for a particular electron. Okay, there you have it. Remember at the very root, you're just giving an address. 4 numbers for an address for every single electron in an atom. Okay, good work. So proud of you. Learning this, man, quantum mechanics, you're doing really well. Be proud of yourself. I'm proud of you. Good job. Thanks.